welcome to Ladyada.
Hey everybody, and welcome to my desk. Happy Easter Sunday. Did a little bit of engineering, slowly getting out of my sales tax reporting party, and back to doing hardware, which is what I'm paid to do. So this week I worked a little bit on this camera cowbell, and I'm working on this ESP32-C6 Feather. So let's go to the overhead, and I'll show off this cowbell. I think I designed it on a previous desk of Ladyada. I definitely remember doing a great search about this micro SD card slot. It's much slimmer than the ones we tend to use. It's a little bit more expensive. It's like a Molex part, but it works great and it's nice and slim, so it fits in between the holes for the cowbell. And this is meant to go on top of Raspberry Pi Pico or Pico W. So you pop it on top. And let me see some camera stuff down here. Hold on, I got a pile of cameras. So what's nice is that this connector, which I think we also did on a great search, can fit a wide variety of cameras. They're called DVP cameras for like digital video parallel or something. I don't know. But you've got like ones with, like big wide angle lenses and ones with autofocus lenses, like the ones in the Memento. So a couple of different options. I tend to like the OV5640 cameras. They're kind of the highest resolution. So you can just fit these in. This pops open, and then this part fits in. Even though this is a very slim connector, it does fit the camera. Wait, hold on. It's really hard to do stuff under a camera lens. Let me get this fitted. You push it down, and then there you go. And then this camera can attach on top, and then you have a micro SD card. STEM QT port if you want to add more sensors, and then like one button. Only thing is it uses a lot of pins. So this uses pretty much every GPIO down here because you need power down, reset, H-sync, V-sync, pixel clock, and then 8 GPIO, and then I think that's it, but it's a lot. And then, the SD requires chip select and SPI and need I2C to control the camera. So you use like a lot of pins, but it does work. And we basically have CircuitPython and there's Arduino support for the ESP32 via the ESP32 camera library. But we also do support it with the RP2040, which, and like, it's kind of nice to have multiple chips supported. So this is the breadboarded version. This is how like I actually tested these modules initially. So you can see it's running CircuitPython 8, and you can see here it's got a little demo where it's grabbing the bitmap, raw bitmap image, and then displaying it on a TFT. But this is, we do document this, but this is like a total pain to wire up. You need like so many, like I said, you need like 15 wires. So this is basically the same code, but now I've got the camera bell on top with a little OV5640, an SD card, and then you've got a little TFT screen, and I just use an iSpy cable to connect it up to a Raspberry Pi. There's me. Hi. Much easier to wire up. I wish it could have fit a display on here too, but it was too small. One thing I did realize as I was doing this, it wasn't working at first, is to save one pin, I have an external crystal. So we don't use a PWM to generate the clock that is required for the camera. And even though the clock is, in general, 24 megahertz, actually 24 megahertz, that's because the data sheet says typical 24 megahertz. It's actually a little bit too fast. So for now, you can kind of barely see I have a little jumper wire where I do generate the PWM from the A0 pin. But then for the final version, I'm going to use a 16 megahertz crystal oscillator. But that's fine. And then this demo also takes photos. So, I can snap a photo, and I think, let me see on the computer. Oh, maybe this isn't the, Oh, you know what? This isn't the demo that takes photos. That must be a different demo. Sorry, I loaded the wrong code on here. Shutter fell. No, it says shutter fell, but it's not detecting. I don't know. Mystery. Anyways, but it does have the echo image, and then I did get the camera to take photos and save them to the SD card. I also have a demo, trying to do it really fast, but I don't know if it's going to work, to be honest, where I have it as a web server. So give me a second. And I'm carefully remove the Pico. One thing I don't like about very narrow boards is that they removing them is easy to bend the pins. Okay, and then I'm going to put this Pico. So the only thing with the Pico W is the Pico W uses a lot more RAM because it has the SSL stack, you know, the Wi-Fi stack it has to do. So ironically, you can't run the demo that echoes the image onto the TFT with the Pico W. Oh, you know, it's funny. I think I had the wrong webcam. Okay, so let's go to the computer. And let me see. Let me connect to Adafruit because it's on Wi-Fi and I'm not Ethernet. It's like a different network. Let me see if that'll work. Okay. And then hold on. Oop. What happened to my Sorry, what happened to my connection? One moment. Okay. Weird. Okay, so this is the TFT version. Let me close that. Okay, found it. Okay, sorry about that. So let's go to this. Oh, let's go to this URL. Let's see if this works. Okay, so now this is the webcam demo, which is streaming the JPEG from the camera to you know, a web server running with async IO. So this demo, I totally ganked it from Jepler, and it was running on the S3. It does run on the Pico W. It's like a little bit slower and you know, not as big because basically you don't have enough RAM to like buffer a gigantic JPEG. But it does work. Is this the demo? Hold on. No, sorry, this is the wrong code. One second. So many Circuit Python. Okay, yeah. So this one creates a server using the HTTP server library and to host it. And then, you know, when you connect, it basically it streams a JPEG image of the size requested, which I'm just doing 240 by 240 again to keep it small. And like it does kind of work, although once in a while it kind of hangs. You have to like reset it, but it does work. Anyways, so those are the two demos I tested and I got working with the camera. I think, you know, this streaming video is, you know, it does work, but it's a little slow. But what this could be good for is, you know, you have a camera on a Pico W and it like senses something and sends it to Adafruit IO, or it sends you an email with the image. I do like that these cameras both have raw bitmap that you can do like simple machine learning stuff on it, like recognizing like numbers and shapes and maybe like a cat or a dog. Or you get JPEG images and then, you know, it's small. There's only like 11K of disk space for a 240 by 240 image, and then you can set up. You can see it's not a bad quality image either. Okay, anyways, so it's the camera, and then well, let's just go straight to the C6. Okay, so the next thing is you can go back to the overhead. I've got this ESP32-C6. So the C6 is an interesting beast because I thought it was like the C3, and it is a little bit like the C3. But instead of, I think it doesn't have Bluetooth Low Energy. Instead, it has 802.15.4, so it can do Zigbee, which means it's good for Matter, which is like a new standard for home automation and IoT stuff. Also apparently very, very low power. I can get down to like, I think like 10 microamperes and deep sleep. Only downside is there's not a ton of GPIO on this module. I like using the modules. I know like you can get the raw chips and sometimes there's more GPIO available. It doesn't have PSRAM. And I think like 2 of these pins I had to share with like SPI or I2C. There's like 2 pins that were like, they were analog pins, but they're also, I think, like these 2 pins, like D6 and D7, are shared with A4 and A5. But you get the STEMMA QT port, NeoPixel, boot button, reset button. It doesn't have native USB. It has the like C3-esque USB that is like, it's a you don't need a USB serial converter, but it doesn't do anything more than USB serial and JTAG decoding. Battery, USB-C. I put a little BME 280 on here because I figure if it's going to be doing matter sensing, like a home automation, it could be a nice demo to be like, oh, like plug it in and it's like an instant temperature, humidity, barometric pressure sensor that can send your, you know, that environmental data to like your home kit or what's it called, home assistant configuration. So I'm just starting to bring this up right now. I have to do like the board definition and the variant, but again, luckily because there's no native USB, it's like not that hard. Also, there's not a lot of pins. So just setting up the setting up the I2C pins, the SPI pins. So the first thing I did is just get the GPIO blinking. It's also, this is a RISC-V chip, not Tensilica, apparently. So, you know, I think it's interesting. We're seeing companies kind of move from ARM and Tensilica, maybe using RISC-V, as RISC-V is adding more capabilities, peripherals, and for like a low power chip, you know, maybe they don't need the, you know, they don't basically, you know, at the low cost of an expressive chip, they don't want to pay the 25 cents, whatever licensing fee per chip, 10 cents, 25 cents. It adds up when you're selling tens of millions of chips. So it also gives them freedom, like in the long term, you know, as if they build on their RISC-V success, they'll do more with RISC-V. So hopefully by next week, I'll have this up and running. I just started like an hour ago making the board definition. So like, you know, did the git clone and like, you know, made a branch. So I think that's it. That's kind of what I'm working on. The camera stuff's done. So I ordered the PCBs and then the C6. I'm very close, I think, to getting it going. And maybe I'll show a demo. Maybe my next week I'll show the low power stuff. And maybe I'd love to do a Matter demo. We have Apple devices in this household. And so it'd be cool to see if we could get it to work with Matter with like a HomePod or HomeKit type thing. I don't know. I'll figure it out. Anyways. Okay, great. I guess we'll go to the Great Search then.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thanks, DigiKey. Every single week, Ladyada uses the power of engineering to help you as you find the things you want on digikey.com. Ladyada, what are you looking for this week?
Okay, I saw this request by Jeff Kaiser, who's a friend of the Fruit. It says, I bought a 1% metal film resistor from AliExpress, but the first resistor is off by 2%. And they're really, really skinny leads. Anyone know a better 1% resistor kit? Glad you asked. But first, let me show on the overhead what he means by skinny leads, because I've actually bumped into this issue and it drives me crazy. So this is, you know, what is often sold when you buy inexpensive resistor kits. And these are often called like 1/16 or 1/8 watt resistor. And the leads are 0.34 millimeters or 0.3 millimeters. Yeah, 0.34 millimeters. Whereas your standard, like what you would normally get, like when most people buy quarter watt through hole resistors, are 0.5 millimeters. And the reason this actually matters is when you use these with a breadboard, you know, these resistors stick nicely, and like, you know, I can't beam the feeling through the video, but like it feels like it's gripped, like it's in there. It's like it's not gonna fall out. It's like it's stuck in there. Whereas the thin leads, they do, you know, there's a little bit of a grip, but like it feels like quite loose, like this one. Here, let me see if I can. Yeah, hold on. Let me show if I can see if I can demo that live. So, you know, there was one slot that was like a little bit looser. Hold on, let me find it. Okay, so it's in here and it just fell out. It's not thick enough to get gripped by, even though this is a pretty good quality breadboard. These are the ones with like the extra prong, and the prongs are like notched to like have a good grip on them. But yeah, it's like unless you have a super tight breadboard, these skinny leads aren't going to fall out. So luckily, DigiKey actually stocks resistor kits. I think we covered SMT resistor kits a while ago, but let's show what they've got for through-hole resistor kits. So over at the computer, under kits, or you can just type in like, you know, resistor kit if you're not going to remember. And they actually have quite a few resistor kits. So let's look at just the active ones. And then, like I said, they have surface mount and through hole. Let's also look also at the, well, we'll do marketplace, but let's do normally stocking, just in case there were some that were discontinued. So to be honest, basically, if you're going to get, you know, like SparkFun has a resistor kit that's a 1/4 watt, but this is a 5% set. You know, to be honest, like a lot of people who want resistor kits want a surface mount resistor kit, not a through hole, because honestly, not a lot of people do through hole prototyping anymore. That said, there is like a Yagio through hole resistor kit here. So let's filter by through hole only. Another thing is, most people don't need a 1% kit. They want a 5% kit because a 5% kit is, again, is going to be good enough for them. But if you do want a 1% kit, let's search for 1% tolerance. I don't know what this one is multiple. I don't know. Okay, 21 options. So the most popular pack of kits, so like, you know, this looks like it's probably okay too. But the Yagio kits are kind of like the ones that they have the most in stock for. But one thing to watch out for is you don't get like every value. So each order that you get has like 1 decade's worth. So this is the 100K to 1 mega ohm, and this is the 10 to 100 ohm, and this is the 10K to 100K ohm, and this is the 1 to 10K. So basically, you like pick which decade you want. Now the thing is that Jeff's like, oh, I don't want to get all of them because it's going to be like $250. But the thing is, like, you probably don't need all of them. I'll say that for most times you need 1% resistors is when you're doing like op-amp filters or like other analog electronics. You have to like set a divider like precisely. And chances are, if you're doing that kind of precision dividers, you don't need anything under 1K because you just like don't really do like op-amp feedback resistors or like other analog resistors that are under like about a 1K or so. So if I was going to get the 1% versus 5% kit, I would get the 1% in 100K to 1 meg and the 10K to 100K. And then if you really want, get the 1 to 10K. But I wouldn't get anything under 1K. I'd get a 5% kit, to be honest, because you don't like need the precision at like 470 ohms. And you definitely don't need it for like 10 ohms to 100 ohms. Like nobody's doing 1%, you know, 68 ohm resistors. It's very, very rare. So I think if you're going to like just pick one, I would go with the 10 to 100K because it's like this is kind of where like the most of your values are going to be when you're doing op-amp circuits. So this is my pick for the great search. It's RS4X Kit ND.
Where in the world is that part I need? The great search with DigiKey.
All right, that's a great search. Thanks, Ladyada. And that is our show for the week. We got to do a bunch of baby stuff. You might have heard a baby saying, "Hey, pay attention to me over here."
That's
What we
okay.
got to do? So we're going to do some baby stuff. All right, we'll see everybody throughout the week. Thanks so much.
Have a great weekend.